So in this video, we're going to talk about condensation polymers and hydrolysis. We're going to go through lots of different examples of how you hydrolyze, and it always comes up in exams, so it's a really good topic to do. So hydrolysis of polymers. It can be done with polyamides or polyesters, okay, and it's based totally on whether you use the acid or the alkali to do the hydrolysis. Now, it's a key term. You must remember it's hot aqueous acid, which is hot, H2O, and H plus aqueous. If you see that aqueous in front of it, it says it's dilute acid. Okay, and dilute acid has lots of water in it, and this is hydrolysis, so addition of water is normally an indication of hydrolysis. We can also do it with hot aqueous alkali. Okay, again, that's hot H2O, this time with OH minus aqueous. And again, lots of water there, hence the hydrolysis. Now let's put this to the side and start going through the examples. So the first example is going to be with an amino acid, and that amino acid is going to be alanine. So we're just going to draw a simple amino acid and then show what happens when you hydrolyze it with hot aqueous acid. So this amino acid obviously has been made into a polymer, okay, and so let's draw the repeating unit to start off with. So there's your C in the middle for your alpha amino acid, there's your R group, okay, and here is your carboxylic acid, and there is your amide. So we've got there, to make it into a repeating unit, okay, there we go. Okay, there's our repeating unit that we have drawn, okay, and let's just finish it off with our hydrogen. So we've got our repeating unit. We now want to know what happens if you hydrolyze it with hot aqueous acid. So first of all, I'm always going to do our acid ones here in red. So we're going to add H2O. Now the H2O is added in two parts, and it's added as an OH or it's added as a H, okay? And that's just simply to try and get it easy in your head to see where the different parts go. And to do hydrolysis, I always recommend you do it in two parts. So the first part is going to be you add your H2O, okay? So we're going to add our H2O in the form of OH and H, okay? And a second thing we're going to do is then we're going to look at what happens when we add the acid. And an acid, if you remember, is a proton donor. Okay, and if you've got an acid that's a proton donor, you just need to look at where you can donate that acid. So if we then look down and we go, right, okay, let's redraw the repeating unit. Okay, because there's our repeating unit. And then we have our carboxylic acid again. And then we have our amine. So we've just drawn it again. Oh, I won't forget my H. I've drawn it again. So we do step one. So step one is add H2O. Remember, we add H2O in the form of OH and H. And the OH will always add on to the carboxylic acid. So the COOH, the carboxylic acid. So when you add it, it will create this OH again. Okay, the H will go onto your amine, okay, and that means when you turn your amine most of the time back into an NH2, it's one of those hydrogens that's added. Okay, so if we look here, we've got our amine right here. Let's add the H. So the H is going to go down here. Okay, and we've had our H on. So we just added the H. From the H2O, we're adding the H2O first. So we've added our H, let's add our OH. OH, as said, goes on the carboxylic acid. Okay, and there's the carboxylic acid. Now here's the important thing. We've added the H2O, so we've done step one. Always do step one, always add the water first, add it with OH and H, okay? And add your H onto your amine, in this case it was a polyamide, and add your OH onto your carboxylic acid side. Okay, or C double bond O, your carbonyl, to make that carboxylic acid. Okay, but then look at this, and what we've got to remember is that let's look for anything that can be a proton acceptor, because now we've moved on to the acid, okay, which is a proton donor. So if we have a proton acceptor, that acid can react with it. And so if I go across here, okay, I'm looking for something basic. Okay, oh right, okay, I've got an amine. Now an amine, if you've done the amine video, is basic. So that can accept a proton. So what we can do is that means that acid is going to donate a proton, and there you go. So as well as that, if you look down on this nitrogen has too many bonds. And as a general rule, if a nitrogen has one too many bonds, it's got a positive charge. And that's because it's got one too few electrons. And you can count all the electrons out here. Okay, and it's made by adding H plus to NH2. So the charges must conserve, as in if overall it was positive at the start, it must be overall positive at the end. So for example, I've added a H plus, so therefore that's going to need to be plus. Okay, if you want to, stop this video, count the number of electrons that are in these bonds, and then you'll see you have one too few electrons because of this dative covalent bond here. Now that means we get this salt here, and that's what you get when you get hot aqueous acid with H2O and H+. Now, we'll show you in later parts of the video how if we name the actual full acid, for example, hydrochloric acid or sulfuric acid, that this becomes a full salt instead of just this positive ion part of the salt, okay? But that is only, for example, when they give you the full formula of the acid. And here they only give you H+, so you don't have to worry about the negative ion of the acid that would stabilise this positive charge. Just give that. Now we'll also go on into later parts to explain what if there's another base here, okay? But again, that'll be in a few slides' time. So we're now going to look at the polyester instead of a polyamide. So if we look here, we can see where the ester is, and we can also see that if you combine this whole thing, put it across here, that you'll have your carbonyl bonded to here. So we've got an ester here as well. So we've got two esters, which means if we're doing this and we're doing it with acid, aqueous acid, and doing this hydrolysis, okay, we need to break both of those. So we're going to break here, okay, and we're also going to break this here, okay, and I do the same thing, absolutely same thing. So one is I add the H2O, and remember, best thing to do is add it as OH and H. Remember the OH goes onto the carbonyl to create the acid, and the H goes back on to the alcohol. Okay, and then I look at my acid and see whether it reacts. Now you'll often see this just written as down there H plus aqueous, or you'll see it with hot H2O and H plus. Okay, so if you see anything that says H2O H plus and it's got in those brackets aqueous, for example, you're going to do this. Now, if I then try and break this apart, so I'm going to break this apart and just draw it again. So there, I'm drawing it again, okay, and then I'm breaking it here again, and I am drawing again the other side. Okay, and there we go, and I've just drawn the two parts again, okay, and then I follow my system. My system is add the H2O back in, it's hydrolysis, add the H2 back in. I'm going to do one H2O at a time, so I'm going to do, there is my OH, okay, and there is my H. So I've done one H2O, put that back in. Again, here's a carbonyl, I'll add my OH there, and I'll have my H. Okay, that means you'll get two different products, okay? Now you notice on this one with the polyester, it's probably the easiest one because the acid afterwards is not going to do anything. So if you look here, you can see an acid is not going to add protons to an acid, and the alcohol is slightly acidic, and so you don't get any acid reacting with that and donating protons either. So there's two examples we've gone so far, polyamides and hydrolysis with acid, and now polyesters hydrolysis with acid. So we're now going to look at doing this with hot aqueous alkali. Okay, that is going to be with sodium hydroxide, for example, things like that. But for now, we're just going to add OH minus, okay, so hydroxide, and that's all we're going to do. So we do it in a very similar way, okay. What we're going to do is, first of all, we add our H2O again. And our H2O is going to be H and OH. Okay, so do exactly the same way. Number 2, then we're going to see what our alkali does. And our alkali is OH minus. Okay, and that alkali is OH minus. Now that, instead of donating protons, accepts protons. Okay, so because it accepts protons, okay, we have to look and see on this product which part of it will accept protons, okay, which would donate protons, so this can accept protons. So which part would donate protons, so that alkali can accept protons. And again, just put it in here. There's our OH minus aqueous. So if you see that aqueous, it just means there's plenty of water there. Okay, and you can do hydrolysis. So we then carry on. Here we have, we're going to draw it out again. And again, there's nothing stopping you doing this before me. Please don't watch the video and just watch. Do something while you're doing it. So here we go, we've got, and again, got to keep remembering my H. Okay, and then we do, as I said here, and we put our H and OH. Now OH will go on to create the, okay, it will go on to create the acid. Okay, and then we will get the H to create the amine. Okay, so we've done that. Now that would be okay, but you're missing the second part. So the second part is alkali accepts protons. So which part of this will donate protons so that to make this OH minus into H2O, for example? And there you go, there's your acid. Your acid is here. So that means it's going to donate its proton. Okay, so the proton's gone. Okay, and that proton is going to be added to the OH minus. So essentially, OH minus plus H is going to be plus H2O, okay, when that reaction happens. If you donate a proton, you leave behind a carboxylate. Okay, your proton's been donated, it's reacted with the OH minus to create H2O, okay, and you have this carboxylate, and the amine here is a base. It can accept a proton, but it can't donate that proton to allow the alkali to accept it, okay? So therefore, this is how you take a polyamide, in this case an amino acid that's been made into a polymer, okay? Add your alkali, you do the first step, H2O, H and OH, put the OH on the part to make the acid, put the H on the amine. I'd really recommend that in the exam you do this with a pencil, because if you do it this way, you're going to have to rub out the H, because the H is going to donate the proton to the alkali. The alkali will accept it, create that H2O, and leave behind this carboxylate. Okay, and that is how you do hydrolysis of a polyamide with hot aqueous alkali. So we're now moving on to doing a polyester, but this time with hot aqueous alkali. So the hot aqueous alkali, again, just to remind you, you can put it as OH minus aqueous, or you can just put H2O, HO minus, okay, like that. So it can be in different ways. So as we come down, we need to recognize again, where is our esters? Okay, so where is our ester? So our ester is here. And again, if we move this to the side, our ester would be at the end here, so would break between here and here, which is essentially there as well. Okay, so we've got this, and then we just draw it back out again, and we do exactly the same. Remember, the step 1 is to add the water as H and OH. Step 2 is to see what the alkali will do. Okay, so let's redraw it out, and we've got breaking the bond there, and then follow it through. So there's your benzene. Okay, and there is your. Okay, so we've just drawn that. Then we go to the O here. Okay, this time we've got the O there, and then go. And we've got that done now. Okay, we then take this H2O. Remember, we're splitting it up into H and OH, and the OH is going to go onto there. Okay, and OH onto there, my H. And if you do this quite a few times, it becomes easier and easier and easier. Now, At that point, we want to see what the alkali does. Well, the alkali is going to react with acid, okay? It's a acceptor of protons, so it needs donator of protons. The only acid thing here we've got is these carboxylic acids right here, so we need to get rid of that, to get rid of the H. Okay, and then get rid of this H as well. Okay, so that would leave us with a O, which has donated a proton, which means it'll have a negative charge here and become a carboxylate. And remember, when the OH minus reacts with the H that's donated, it will create water. Now, that is now how you take polyesters and you hydrolyze them with hot aqueous alkali, okay, and we've also done polyamides and how you do those with hot aqueous alkali. So now we know how to do hydrolysis and the way to do it. We're going to complicate it a little bit by putting extra groups in to see what happens. So things like amines, carboxylic acids, and alcohols, okay? So first of all, with alcohols, they don't really do anything. So don't be looking at an alcohol and putting on a proton or taking off a proton when it comes to these things. Alcohols don't really do anything. So just avoid that mistake. But carboxylic acids, as you can see, there's a carboxylic acid here, and amines, okay, they can be some complications. So if you look here, we've been presented with a repeating unit just on here and here, okay? And this is an interesting one, actually, because if you had this, this actual molecule, you could do different polymers, because obviously you can have this, for example, if it was an acyl chloride reacting with this, and you could also have that end reacting with here and all sorts of things. So one thing that might be good for you to do is just see how many polymers or different types of molecules you can make by reacting this with itself. I do that in class and it works really well. So anyway, let's go back to this. We're going to see what happens if you use aqueous acid here. And we're going to do exactly the same thing as we've done again. Okay, we're going to break this. We know this is the ester. Okay, so we're going to break it and redraw it. Okay, so there we go. I've taken off those little dotted bonds. Okay, and then I'm just going to go, right, okay. And I'm going to draw this out like this now. And you'll see why in a second. Okay, and then that goes down. And you will have your OH. So I've broken my ester. Okay, I've redrawn those out, and I'll explain why in a minute. And I'm reacting it with aqueous acid. Remember, this can be H plus / H2O as well. Okay, so before I do that, I'm going to put my bits back in. So I'm going to put my water back in. There's my OH, and there's my H. So it's got an alcohol, for example. It's got a carboxylic acid. It's got an amine. It's got another carboxylic acid here. So we need to know, what does the H plus do? Okay, we know it doesn't react with the acid, we know it doesn't react with the alcohol. But there's a base there, and let's remember as well, this has got a lone pair of electrons. Okay, so therefore, if I'm going to add acid to it, that's a proton donor, that's a proton acceptor, and there we go. And we have a bond there and an H3. And remember, too many bonds means a positive charge on that nitrogen, okay? So my point being is, if you're doing this kind of thing, don't just do the ester part there. Look around the group and see if there's anything around the group that actually reacts with the acid that you've got, or in the next example, alkali. Okay, there's an easy way to catch out, and usually they'll give you the mark for this part and then the extra mark for that. So it'll be a mark you're missing out on if you don't practice this kind of thing.